Hi, in this video today we are going to watch and find out how to determine the average mass of an isotope. So sit back, relax and let's watch the video. Welcome to Chemistry Videos. Today we are going to talk about isotopes and how to calculate their atomic mass. So, what exactly is an isotope? Carbon has three different types of isotopes: carbon 12, carbon 13 and carbon 14. Which means the atomic mass for carbon 12 is 12. The atomic mass for carbon 13 will be 13 and for carbon 14 it will be 14. Carbon has an atomic number of 6 and that atomic number remains same for all the isotopes. So, this is carbon 12 isotope with atomic mass number 12 and atomic number is 6. This is carbon 13 isotope and this will be carbon 14 isotope. As we know, we can find number of neutrons if we know the atomic mass number and the atomic number. It is simply subtraction of two numbers. So number of neutrons for carbon 12 will be 12 minus 6, which will be 6. For carbon 13, it will be 13 minus 6, which will be 7, and for carbon 14 it will be 14 minus 6, which will be 8. So isotopes have different atomic masses and also different number of neutrons. Like carbon 12 has 6, carbon 13 has 7 and carbon 14 has 8 number of neutrons. So let's summarize. Isotopes of an element have same. What is the same? The same is atomic number, and if atomic number is same, they have to have same number of protons, because atomic number and protons is always equal. So what is different? We just saw it. The atomic mass number and the number of neutrons. These are the two different things in isotopes. Okay, so how do we find out the average mass of an isotope? Each isotope will have its own abundance, own proportion. And to find the atomic mass, we simply multiply the fractional abundance with its mass number and we add all those products. And that way we can get the isotopic mass. Now let's really solve some problems to understand it better. Okay, in this problem, we are talking about neon. And neon has 3 isotopes. The masses are given for each isotope. We have first one, the mass is 19.99 and in same sequence the percent will be 90.92. The second isotope will be 20.99 with a percentage of 0.25 and the third one has 21.9 as the mass number and we have percentage as 8.83. So if you want to find out the percentage and the abundance, they are a little different. Percentage is actually out of 100 and when we find out the fractional abundance, that's the decimal point, decimal fraction which we get. So let's say 90.92%. 90.92% means It is 90.92 out of 100 over 100, which means that will be equal to 0.9092. So what we got, that 0.9092 is considered as fractional abundance. So let's find out fractional abundance for each of the isotope. As we know, from 90.92, the fractional abundance is 0.9092. For 0.25%, it will be 0.0025. And for 8.83, it will be 0.0883. We are just moving decimal point to the left side by 2 places. And then, as per our definition, we find the atomic mass by multiplying the fractional abundance with the mass number. So the mass number for 9092 will be 90.99. For 0.0025, the second number, it will be 20.99, and for the last one it will be 21.99. All these products which you are going to find out, we have to add those. So when we add these products, whatever we get is the final answer. And that answer turns out to be, in this case, 20.17 AMU. Okay, so that's one kind of problem when all 3 isotopes, the mass is given to you and also the percentage is given to you. The other kind of problem which we can see is little different. In this case, what is given is the mass number for isotope and the average atomic mass. We have to actually find out the percent abundance. So this is silver, and silver has 2 isotopes, Ag107, and the second one is Ag109. What this means is Ag107 means the mass number for Ag107 is 107, and for Ag109 what we have is the mass number is, sorry about that, mass number is 109. So when we have to find out the percent abundance, if we don't know exact values, we can consider the fractional abundance is equal to X for this, and maybe for this one it is Y. If X and Y are percentage abundance, and then 107 and 109, these are the mass numbers, we can easily multiply these two things and we can add these in order to find out the total average mass. So in this case, the average mass will be 107x plus 109y, and that answer should be the average atomic mass, which is 107.87. So if you have the average mass as 107.87, how are we going to find out X and Y? X and Y are fractional abundances, which means X plus Y is equal to 1. But if you want to cancel out of these two variables one variable, one easiest way to do is match the coefficient for X or Y. Now in this case, I am just going to match the coefficient for X, 107x. So if I want to cancel out that X, I need to multiply this entire equation by negative 107. If I do that, what I get is negative 107x. When you multiply this by positive y, we get negative 107y, and that will be equal to negative 107. So let's put this underneath here. It's negative 107x negative 107y and equal to negative 107. Now, if you are adding the two equations, this is positive, this is negative, that cancels x. This is 109 positive, this is negative 107. We subtract both and we get the answer 2y. 2y is equal to 0.87. When we solve that, y will be equal to 0.87 divided by 2 when we divide both sides by 2, and we will get the answer for this as 43.435. Now remember, this is a fractional abundance. So if I want to convert that to percent, I need to move decimal point by 2 places to the right side. So that will be 43.5%. If y is 43.5%, how do I find out x? In order to find out x, I need to subtract it from 100. So 100 minus 43.5 will give me the other percentage, which comes out to be in this case as 56.5%. So we got the answer. This AG107, which has got the mass number 107, will be 56.5%. So x is equal to 56.5%. And the other one, AG109, will be y, which is 43.5%. So this is pretty easy to find out the percent abundance if we know the average atomic mass. So, what do you all think? Was it easy to find the average atomic mass of an isotope? Okay, practice some more questions and I am sure you all will be ready for the test. Let's meet again in our next video. Until then, goodbye.